All right, let's just jump right into this explainer. Today, we're dissecting one of nature's fastest, most terrifying, and honestly, most fascinating phenomena. We're going to uncover the exact science of how perfectly innocent snow becomes a literally deadly force of nature. Picture this. You're standing on a perfectly serene, snow-covered peak. Skiers are gliding through this beautiful fresh powder, mountaineers are inching toward the summit, and it's just absolute pristine silence. Right up until you hear this deafening whump right under your feet. A crack races across the snow, and suddenly, the entire mountainside just drops. Within seconds, millions of tons of snow are rushing downhill at over 300 kilometers per hour. To put that into perspective, that is faster than a Formula One race car. At that kind of crazy velocity, this snowy behemoth snaps mature trees like they're little matchsticks and completely swallows buildings in a blinding white cloud, before everything goes back to dead silence. Moving into Section 1, Anatomy of an Avalanche, the science of unstable snow. So you gotta wonder, how does something as soft and, well, beautiful as a single snowflake turn into this devastating force of destruction? To understand this, we really have to look at the delicate battle going on between the structure of a snowpack and the relentless pull of gravity. Simply put, an avalanche is just a rapid movement of snow, ice, and sometimes rocks down a slope. Normally, friction holds the whole shebang in place, but the second stability decreases, gravity wins. It actually happens in steps. You see, snow doesn't just fall as one big uniform mass. Every single storm creates a distinct layer with its own temperature, density, and crystal shape. Over time, a weak, unstable layer can develop right beneath stronger ones. It's kind of like stacking a bunch of heavy books on top of flimsy playing cards. As soon as a trigger adds just a bit too much weight, maybe a skier, some high winds, or even just new snow, those cards completely collapse and the books slide. That is exactly how a weak layer of snow fails. Now, you might logically think that sheer vertical cliffs are the absolute most dangerous places to be. But actually, most avalanches happen in a very specific sweet spot, which is slopes angled between 30 and 45 degrees. Why? Well, steeper slopes naturally shed their snow constantly, which stops large accumulations. And gentler slopes hold the snow pretty securely. It's right in that 30 to 45 degree angle where massive, highly dangerous amounts of snow can build up before just releasing all at once. And you know, not all slides are the same. While slab avalanches, which is where large solid blocks of snow break away all at once, are responsible for the most fatalities, the powder avalanche is uniquely terrifying. It generates this massive air blast ahead of the snow, creating a pressure wave that can literally flatten buildings before the snow even reaches them. There are also wet snow avalanches caused by warming weather and massive ice avalanches triggered by collapsing alpine glaciers. It's also really helpful to contrast avalanches with landslides. While they might look kind of similar in motion, their triggers are fundamentally different. Avalanches are uniquely tied to winter mountain weather, so they're driven by sudden wind slabs, fresh snow, or shifting temperatures. Landslides, on the other hand, mostly consist of rock and soil and are generally triggered by rainfall or earthquakes year-round. All right, Section 2, Historic Disasters, a Legacy of Devastation. Looking at real-world impacts, we can see how these unstable snowpacks have triggered some of the most catastrophic events in modern history, and the triggers themselves vary wildly. For instance, in 1970, a massive earthquake triggered a slide in Yungay, Peru, burying an entire city and killing roughly 20,000 people. Absolutely devastating. Fast forward to 1999 in Gultur, Austria, where heavy snowfall caused a deadly slide. And then in 2014, collapsing glacier ice on Mount Everest tragically took the lives of 16 experienced Sherpas. Zooming in geographically for a second, the towering Himalayas create an exceptionally high-risk environment for India. This vast region gets hit with heavy snowfall on incredibly steep slopes, and this constant threat severely impacts vulnerable mountain communities, like we saw during the devastating cascading Chamoli disaster in 2021. But it also threatens critical high-altitude military operations. Think about the personnel on the Siachen Glacier. They face this snowy hazard literally on a daily basis across Jammu and Kashmir, Ladakh, Uttarakhand, and Sikkim. Let's move to Section 3, Fighting Back. Engineering solutions, and forecasting. The good news is, we aren't totally defenseless against these mountains. Today's forecasting relies on this incredible blend of gritty fieldwork and cutting-edge tech. Scientists are actually still out there physically digging snow pits to test the density of layers by hand. But now they combine that raw data with remote weather stations, radar, satellites, drones surveying unstable slopes from above, and even AI-driven numerical modeling. So while they can't predict the exact minute a slide will happen, they are getting unbelievably good at identifying dangerous conditions. Forecast centers take all that complex data and compile it into the 5-level avalanche danger scale, ranging from 1, which is low, all the way to 5, extreme. This is the ultimate metric. It tells skiers, mountaineers, and road crews exactly when they just need to stay off the slopes. Understanding and respecting this single chart honestly saves countless lives every single winter. When it comes to physically protecting infrastructure, engineers take some pretty incredible direct action. They build massive concrete snow sheds and galleries that let avalanches harmlessly pass right over highways and railways. They install heavy nets right on the mountainside to hold unstable snow in place. And, this is wild, they even conduct controlled explosions. They intentionally use explosives to trigger small, safe avalanches before massive, deadly ones even have a chance to build up. Okay, Section 4. Survival and Preparedness. What to do before, during, and after. Despite all this amazing technology we just talked about, if you head into the backcountry, your survival really depends entirely on your own preparation. And this brings us to probably the most chilling number in snow science, 15 minutes. If buried, your absolute best chance of survival relies on being rescued within the first 15 minutes. Why? Because once avalanche snow stops moving, it compacts. 1 cubic meter can weigh hundreds of kilograms, setting as hard and as heavy as concrete. Self-rescue is practically impossible. So survival really comes down to strict protocol. Before you go, you absolutely must check the forecasts and always carry a transceiver, a probe, and a shovel. During an avalanche, if you're caught, try your hardest to move sideways out of the path, drop your heavy gear to stay near the surface, and crucially, cup your hands over your mouth to create a vital air pocket before the snow sets. And after the slide stops, your companions are your rescue team. Do not wait for external rescue to arrive. You have to start searching immediately.
Oh, and let's quickly bust a very persistent Hollywood myth right now. We've all seen the movie where someone yells super loudly and brings the whole mountain down, right? Well, fact check. Normal voices simply do not carry enough force of pressure to trigger an avalanche. It actually takes the physical weight of a human, heavy fresh snowfall, warming temperatures, or really high winds to collapse that weak layer.
On to our final section, Section 5, the future of mountain safety, technology versus nature.
As climate change continues to mess with freezing and thawing cycles globally, the way we manage these disasters is evolving super fast. We're stepping into an era of just phenomenal tech. We're talking AI-powered forecasting, autonomous drones monitoring slopes 24/7, and smart highways embedded with early warning sensors. We're even seeing digital twins, which are basically exact virtual replicas of mountain ranges running real-time snowpack simulations. And we're seeing robotic systems being developed that could one day assist in those absolutely critical 15-minute rescue windows.
Every single snow-covered slope tells a complex story of layers, weather, and weight. We can never turn off gravity, and we're certainly never going to stop the snow from falling. But by understanding the precise science of the slide and pairing it with our rapidly advancing technology, we can learn to truly respect the mountains and save countless lives in the process.
But looking at all this incredible tech on the horizon, it really leaves us with one final provocative thought. We cannot stop snowfall or gravity. But as our technology evolves, will we ever completely tame the world's deadliest mountains? Thank you so much for joining us for this explainer. Remember to check those forecasts, always carry the right gear, and respect the snow. Stay curious, stay safe, and keep exploring.